For as long as we've been human, we've looked up at the night sky, at that big, bright circle, and wondered, where did the moon come from?
You know, poets and dreamers, they've seen it all in the moon. A god, an inspiration, even a lover. But if we look past the poetry for a second, what's the real story? How is it actually made?
Well, long before we had telescopes, our ancestors came up with their own answers. They told incredible stories, weaving the moon and its cycles right into the fabric of their lives. Let's start there.
Take the Yolngu people in northern Australia. For them, the moon was a man named Galindi. In his story, it's a perfect explanation for the lunar phases. He gets fat, which is the full moon, then gets bits chopped off him. That's the waning moon. He dies for 3 days, the new moon, and then he's reborn and grows fat all over again. It's brilliant.
Another amazing Australian story tells of an unlikely hero, a weak old man who throws this giant, shining boomerang. He throws it so high and so hard that it just gets stuck up there, lighting up the night sky for the rest of time.
And it's not just ancient myths. What's really fascinating is how major world religions also gave us these profound explanations. Whether it's being churned from a cosmic ocean or spoken into existence by a divine command, each story ties the moon to a purposeful, sacred act of creation. But then you have science. And science asks a totally different kind of question. It doesn't ask why, so much as how. It treats the moon's origin like a giant mystery, a cosmic crime scene, just waiting for someone to come and analyze the clues.
So to solve a case like this, what do you need? You need evidence. Our detectives, in this case astronomers and geologists, knew that any theory, any suspect, had to be able to explain a few key non-negotiable clues. And they found 4 of them. First, the moon and Earth are like chemical twins. Second, the moon is weirdly missing a big iron core. Third, the Earth and moon spin together with an incredible amount of energy. And finally, thanks to the Apollo missions, we know exactly how old the moon is, about 4.5 billion years old. Now, that first clue is absolutely crucial, this idea of an isotopic signature. Just think of it like a chemical fingerprint. Every planet, every asteroid has its own unique one. But here's the mind-blowing part. The moon's fingerprint is a perfect match for Earth's. They're identical, unlike anything else in our solar system. So, with all this evidence on the table, all the clues started pointing to one primary suspect, a theory that involves a collision on a scale that is almost impossible to imagine. It's called the giant impact hypothesis. Let me introduce you to Theia. Theia was a rogue planet about the size of Mars that was wandering through the early chaotic solar system. And the theory goes that it was on a direct collision course with a very young, still molten Earth. Now, this wasn't a head-on crash. It was a violent, glancing blow. It was so powerful it basically vaporized a huge chunk of Earth's outer layers, blasting trillions of tons of molten rock into space. This debris formed a massive glowing ring around our planet, and over time, gravity did its thing, pulling all that rubble together to form the moon. The energy from this impact was just immense. We're talking temperatures over 10,000 degrees Celsius. That is literally hotter than the surface of the sun. And it's in this unbelievable heat that all the pieces of our cosmic puzzle really start to click into place. Because remember those clues? Well, this one single epic event explains them perfectly. Theia's heavy iron core sink right into Earth's core, which explains why the moon is so iron-poor. And because the moon is made almost entirely from Earth's own vaporized rock, of course their chemical fingerprints match. It's our fingerprint. But, in science, a good answer always leads to even better questions. So even though this theory is our leading suspect, the case isn't completely closed. The story is definitely still evolving. I mean, we know for sure that some of the older ideas just don't work. The idea that the moon was a passing wanderer captured by our gravity, or a chunk that just split off a fast-spinning Earth, they just don't hold up when you look at the hard evidence we have today. But even the giant impact theory has this one little nagging question. If Theia was a totally different planet, why is the moon so incredibly identical to Earth? And that's led to some newer, even wilder models, like the idea of a synestia, a giant spinning donut of vaporized rock from which both the Earth and moon reformed. Or maybe it wasn't one giant impact, but a bunch of smaller ones over millions of years. So, okay, we've gone on this huge journey, from ancient stories all the way to cutting-edge astrophysics. Where does all of this leave us? What should we take away? Well, we've seen two really powerful ways of understanding our world. One way, the myths, asks why. It's all about finding meaning and our connection to the cosmos. The other way, science, asks how. It's about evidence and physical mechanisms. And really, both are just essential parts of the human quest to figure out our place in the universe.
And that brings us to a final thought to leave you with. Our relationship with the moon is changing. We're going from just looking at it to actually going there, to building, maybe even to mining it. So the question is, what new myths, what new stories, and what new meanings are we going to create then?